All right, let's go ahead and get started with today's webinar. My name is Aaron Bartlett, and I'm one of the account managers here at Qnect. And today, I'm joined by Josh Hines, who manages our technical field support. Our webinar is focused today on understanding the true ROI of Qnect, and Josh will be leading us through the value as it relates to specific roles in your projects. Now, before we begin, a couple of housekeeping items. First, attendees are in listen-only mode. We do encourage questions, and we'll have a short time of Q&A at the end, so please use the chat box on the right-hand side of your screen to ask questions as we go. With that, I'll turn it over to Josh to guide us through this webinar.
All right, thanks Aaron for the introduction. So today we are going to talk about the understanding the true ROI of Qnect, or the return on investment. So we're going to go through a few personas, right? So we're going to go through the detailer aspect, fabricator, erector, connection engineer, and engineer of record. As we go through these, I'll touch on these areas. For instance, the detailer, I'll talk about schedule advancement, and for the most part, that's going to also apply to the other categories. So for time purposes, I will not be going through each one of these categories for each item. So that being said, let's jump into detailer. Right, so you'll notice in each one of these, if you see a white font, that applies, as you can see on the right-hand side of our screen as well, and the ones that do not apply will be in gray. So let's look at schedule advancement. Right, so schedule advancement, when it comes to us, what does that really mean? Well, when we get into an environment with modeling, at least from a detailing perspective, we have a stick model. There's no connections, and we have to then go in, start designing some of this, or taking the design that's already provided to us, or a mixture of both, and then starting to create those connection components in Tekla, manually. Well, with Qnect, you don't have to do that. So typically 60 to 80% of your structure is going to come in not only connected, as you can see, but also with the calcs. So we have all the backup for those connections we've been able to do. So think of what that will do from a schedule standpoint. As a detailer, obviously there's speed for schedule. And following down the line, what's that going to do for everybody else's schedule getting in front of things? All right, let's get into RFIs, earlier RFIs. So typically with an RFI, you're not going to get into an environment until you hit it, right? So as a detailer, you may be working on the first sequence, as you can see highlighted here. But, why not look further up the structure? And you really have the ability to do that with the connections. So imagine looking in this area knowing, I couldn't connect some of the connections up in this area, but I can now have somebody go in and say, this is more unique. It doesn't really work with the specific design criteria provided. So I can actually ask an RFI early on, and I can have that back with the answers or sketches, the information I need, so I can actually model that in once I get to that point without having to ask an RFI later. And then faster in-model connection design. So, obviously this kind of pertains to schedule as well, but, we're not only getting connection design early, right? It's actually being modeled. So it's faster in the form that it is physically being placed into your model. So once the model has been prepped and the preferences have been completed, you're literally looking at 3 to 5 connections a second. So we're going to go through some of these projects very quickly. 50-ton project can be completed typically 1 to 3 minutes. 100 tons, 3 to 5 minutes. 500 to 1,000 tons, 15 to 30 minutes. 2,000 to 5,000 tons, completed typically less than 2 hours. And 10 to 30,000 tons completed in less than 4 hours. So most of our projects result in 60 to 80% of the structural connections being completed in an initial run. We know some of our users don't always do an initial run, as far as time savings. They may just do a run of the entire sequence that they're working on, but you have the ability to find out that 60 to 80%. You can go ahead and back out of the model, take it back out of the model, but you can at least know the value of what you're going to be expecting in this project up front, and that's that 60 to 80. Let's move on to beam web reinforcement and the awareness of that. So there's a couple things here. On most projects, nobody really knows where these are going to occur from any level. So not only are we aware of them and we can provide a report showing this information at beginning stages, we will also model this back into the model where it applies. So for instance, we have a 12 by 14 that requires 37 kip reaction. And we were able to meet that with only a capacity of 32.27. So we require a 5/16 by 9.5 by 8 inch web reinforcement plate, as you can see in dark green on the screen. So not only do we know that it exists, it's been modeled in. You can see that all the welds are associated, so everything's 100% modeled in there. And we also have a report showing that we only met that at a 32 kip capacity. So go ahead and look at the first line item. It requires 15 kip reaction. We met that with 14 kips. Well, something like this could be very valuable that we can provide to a connection engineer or an engineer of record and say, listen, do we really need 37 kips? We're able to make it at 32. Can you reduce that? Dig into this and see if we can remove these from the project. A lot of time savings in the shop and less hassle with a general contractor trying to negotiate changes later. So now let's look at modeling quality and the accuracy of that, as well as the accurate reporting that can come out of the model. So as you see on the screen, not only do we bring the connections in, they come in accurately. Everything's there. It's not just some of the information. Field bolts. Not only are they modeled, they are there. You can report that information. Same with shop bolts. You're going to get the right quantities, right size, right length, all that information you're looking for. And then this is the very important one for most of us, is the welds, right? So unfortunately, in a lot of cases, in past experiences, and we've heard this from a lot of our users, is welds are not accurately placed in a model, so then they are manipulated later on the 2D drawings, as well as changes come through, the manipulations don't follow through again. It's no longer automated from the model, so it becomes a problem where you're not having accurate welds. That being said, we bring everything in our connection component. You're going to get the exact length that you're looking for. You're going to get the size and type of weld as well as a volume. It doesn't really get any better than that. Now let's look at a faster submittal review process, whether this is a review with the CE, the connection engineer for the fabricator or detailer, or whether this is an actual submittal for approval with the EOR. So with Qnect, we can provide, you can accomplish providing a 2D code map. And in that code map, you'll notice that we have our start and end handles. And along with that is going to be a connection code. You can also, if you'd like, you don't have to, but you can also have the reaction required and the capacity in which we met that. And you can also create a code map simply from copying your framing plan that's already been done, and then just taking the template information that we give you, and you don't have to do all that extra legwork. You'll also notice that this is coming from a shop drawing. The same information can be placed onto a shop drawing, as you see here. And we can help make custom templates that'll be used for shop drawings. This was for an EOR. They wanted to see that same type of stuff, the start and end handle information. but they also wanted their approval stamp associated to that. So you can see how that also helps. Now let's jump into fabricator. So like I said before, that's the detailer aspect of things. You think about how that really applies to your category as well. There's speed, there's schedule with all of that, but really think about what that does for you. So now that we're with the fabricator, you can see that bolt reduction and hole reduction are the next two items. They kind of go together. So bolt reduction and hole reduction, what is that really? Well, for us at Qnect, we have the ability to adjust the vertical spacing in a connection. So typical or standard connection that we've been used to over the years is a 3-inch vertical spacing. Well, with a lot of the automated equipment out there now, why not adjust that spacing? We're not manually laying these holes out, so why not adjust that spacing and reduce 20 to 50% of your bolts on a project? Who wouldn't want that? What erector is going to say, I don't want to do that? Their bolt up gang is going to come through, and in this case, it looks like it went from 12 to 6. Their bolt up crew is going to come through, and they only have to stuff half the bolts. And at the same time, the inspection only has to be half of those bolts. And we'll get into that next. So, like I said, typical reduction, 20 to 50% of the bolts. Now, let's look into mill order savings. So at a fabricator level, if you're doing, whether it's an initial run or, some very early runs to really yield as many Qnect connections in the model that you can, typically 60 to 80 of those connections, imagine before you order anything mill direct, you have exact lengths for those members, right? So those exact lengths, which we've seen, they definitely have potential for price lock with the mill direct orders. If you have exact lengths and tonnage, you're not going to be going back and adjusting that, and they're not worried about about not price locking for you at that point. And also lower tonnage just in general, right? So when you order, you're ordering off of a lower tonnage, you have potential of saving some money there. All right, so that's fabricator. Now erector, we talked about bolt and hole reduction. Now let's actually look at inspection reduction. So, just a standard type of a checklist from inspection. Basically, the best part about this is you're not going to see direct cost savings. It's more schedule and I guess hassle savings, from my past experience and stuff that we've heard from some clients as well is, one of the biggest and hardest things in a schedule for an erector is turning over a floor. We've got to turn over this floor so the trades behind us can actually access below and get on that floor, decker, everybody. So that being said, if we have 20 to 50% of those bolts that do not exist any longer on a project, what do you think that's going to do for our schedule? You can determine that yourself, but we should be able to start turning floors over faster or earlier in a schedule. So connection engineer, pretty much the return on investment there is going to be same categories as a fabricator and erector. And same thing with the EOR, engineer record. They're only going to apply in certain areas. Obviously, hole reduction, bolt inspection, mill order savings probably won't play a role for engineer record. Okay, finally, how much will you save? So, how much will you save from schedule advancement? How much will you save from early RFIs? How much will you save from faster in-model connection design? How much will you save from beam web reinforcement awareness? How much will you save from modeling quality and accuracy? How much will you save from accurate reporting from that model? How much will you save from faster submittal review process? How much will you save from bolt reduction? How much will you save from hole reduction? How much will you save from bolt inspection reduction? And how much will you save from mill order savings? As always, if you have any questions, feel free to text, call, or email me at any time. I will get back to you. I'm always here to help. So that will wrap things up, and we will go into a Q&A portion of this webinar.
Great, thanks, Josh, and thanks again, everyone, for attending the webinar today. We do have some questions that have come in, and I encourage you, if you do have some after viewing the presentation that Josh had, please feel free to use the Q&A bar to the right-hand side. Simply put those questions in, and then we'll try to go through these one by one, and I'm going to try to group them together if there are a couple that seem to you have similar scope. So. Josh, the first question that we have here is, how do I get ROI information specific to my project? And I'll go ahead and take this one. So we get asked quite a bit about for projects if there's a way for people to get early data on it. Certainly, we want to understand if it's a good project for Qnect or something that we can assist with. And so the best way to do that is to just pass along the design drawings for the project. We like to get in early with you, and so we'll review those and let you know if it's a project that Qnect could assist with. If it is, we do have an ESTA modeling service, which allows us to not just build a model for you for bidding purposes, but also run it through Qnect. And that would allow us to look at some of that return on investment information early. And so that would be certainly probably the best way to approach it on the front end. If it's a live project that you have where you want to take a look at what could potentially happen, in regards to the return by using Qnect, we certainly could evaluate a Tekla model. So if you have one that's built, we could help you with prepping the model and then running it through Qnect and kind of showing you what types of savings would be available. Where we do that quite a bit as kind of a test measurement of Qnect services. So if there is interest in that, please feel free to send Josh an email, or you can send me an email. It's simply Aaron, Aaron, @qnect.com. So we have another question here. How can I understand which project is good for Qnect? Similar to what I just said, actually. So obviously, we could evaluate either a model or the design drawings for that project. Josh, anything you'd like to add on that end?
Yeah, we're going to be kind of just looking for specific information that has to do with design, making sure it aligns with the type of connections we currently have in our library, and kind of absorbing some of the information to make sure you can best approach your project.
Great. Okay. Next question here. How do I contact Qnect to get this information?
To be frank, as soon as possible. You want to try and get ahead of things. You want to be able to get in early and make the best impact that you can, whether it's a project that you're just trying to keep from going out to bid and you want to position yourself in a better fashion, or whether you're trying to be competitive and you want to have that competitive edge with more data, more information, and a better stronghold on your project before it begins.
Yep, great. I mean, and so, that's the win. I mean, the how would be, for us to take a look at design drawings early, and certainly look at it, as quickly as possible. So, all right, next question, and this is one that we've heard quite a bit. So how do I get, this must be coming from a detailer here, how do I get my fabricator or EOR on board with using Qnect? Josh, you want to take that one?
Sure. So it's all about getting in early and, trying to persuade. So the best time would probably be in an model or estimating environment, trying to bring as much data to the equation that you can, and, really showing your fabricator or EOR, hey, where can we all save here? What's best for the project? And can we put something together quickly, so as soon as this project is awarded or as soon as this project starts to move, we're already in front of that and we can move forward very quickly.
Great. So another question that comes in. This is looks like this is probably from a fabricator here. So we've been killed by web doublers on past projects. Boy, we've heard that one before. Is there a way to set up the job to reduce the reinforcements, or at least know how many we're looking at so we can add it to our bid?
Sure. So yeah, web reinforcements. A lot of people have been burned by those. I think the best way to approach this is really taking that report that we can provide very early, getting that to the design team so it can be reviewed, maybe having a work session if you're able to, and trying to get those loads or those reactions reduced so we can actually get away from the reinforcements altogether. Or if we're going to be stuck with a reinforcement, maybe it can be a reduced reinforcement. So trying to just get away from that. And if it's not only getting away from it, at least up front that they exist, and you can at least qualify that and maybe have some money set aside for that.
Okay. Yeah, that makes sense. So the next question here is regarding NC1 file. So this looks like a fabricator who's asked this question. We typically get an NC1 file for machines. Does your program do this? I'll take that. So the way that Qnect works, it's simply a program that sits, it's actually directly integrated with Tekla. And so this would not interfere with any of the file types that you're getting, any outputs that you're getting from a detailer. So the detailer would still be able to provide any specific outputs, whether it be for like an NC1 file for any of your automated machines, or even an estimating like a KISS file if they're helping you with that. This would not interfere with any of that. You'd still be able to use that just fine. Josh, a question here. How do I determine a real ROI for bolt reduction?
Sure. So the best way, we can't really do that for you at Qnect. It's more how you determine that in-house. Maybe you determine that by how much it is per hole, the labor associated to that, whether it is manually laying that out or whether it is with an automated machine, equipment. And, obviously either way, it's all relevant. You either have man hours or it may be faster, obviously, with automated beamline or something. But, if you reduce 20 to 50% of bolts on a project and you start doing that as much as possible, you're going to have less maintenance on that equipment. You're going to have less, you're going to have less bits and drill bits, stuff like that you're going to have to use, so like I said, it's relevant to something like that. And then as far as erection, it kind of speaks for itself. 20 to 50% of the bolts just flat out not being there, obviously it's going to go great for schedule.
Okay. I guess this is somewhat similar. So I wouldn't get a cost savings for inspection reduction. Is the next question?
Sure. Yeah. I mean, I don't think you'd really get an actual savings specific, an actual number, but you should be able to expect, like I say in the webinar, you should be able to expect to be able to hopefully turn over a floor a lot faster, keep your general contractor happy. I've been in that situation myself where, maybe there wasn't enough time allowed for welding per the schedule or something of that nature. And, that general contractor, their default first thing they're going to do is, hey, I need you to work time and a half until we can make up the schedule. And typically you're going to either do that or you're going to do it for the life of the project because it's very hard to catch up at that point.
Yeah, that makes sense. All right. So we have a couple more questions here. I'm seeing a couple more that have come in. So please continue to keep those coming on the QA side. Josh, the next question here is, how is this better than Tekla Auto Qnect?
Sure. So, Auto Qnect does exist, and you can go ahead and place something in Tekla very quickly by doing that. But the big difference that we have there is we provide calculations for every connection that we bring in. And if a connection doesn't come in from Qnect, it's because there's something with the design that doesn't work specific to the design itself. So we're not going to place a connection in a model if it's not accurate. So there's a big difference there. You can take that calc information, for a lot of detailers and fabricators that do not have in-house engineering, but maybe they want to step up their game and bring that to the equation. They can go ahead and use Qnect, and they can get the majority of their connections with calculations, and then send the remaining for review and everything to the CE, and kind of have a better leg up on competition.
Okay, yeah, that makes sense. All right, so we have a question on the connection types that are supported by Qnect. So what connection types are supported by Qnect, and are vertical bracing connections supported? A little bit of a leading question there, right, Josh?
Yeah, sure. So, we do have on our website the exact connection types in our library, but basically, we kind of started with the gravity connections, more the meat and potatoes in a project, so we can really show a large amount of connections throughout a project and very, very early on with all of the data. And when it comes to vertical bracing connections, we currently do not provide vertical bracing in our library, but join us at NASC. We're planning on rolling out an example of vertical bracing that's coming up very shortly, which is looks to be HSS vertical brace. And then also kind of one other thing to touch back on the Auto Connect. Another thing that we bring to that is we actually have iteration control. And what I mean by that is we can actually control something specific to a shop. So say you have a double angle or a single angle connection, and you have your preferred angle size that you want to use. We have the ability to start with that. And then if that connection doesn't work with that material, we can then start going through the AISC library of profiles. But the iteration control portion is now you can set up all the other profiles in priority order after that preferred, and it'll cycle through those only. So if it's not in that list, if you set that up, it's not going to go to a profile that you don't want to order or that you can't handle in your shop environment.
Yeah, and similarly, just to add to that too. So if I'm a detailer and I want to set up that we'll call it preference hierarchy, right, for the connections, I could do that and templatize it per fabricator, right? So the control isn't just something you have to set up every time. You could actually set it up if you're a detailer per fabricator, or if I'm a fabricator, I could use that kind of moving from job to job. So definitely some speed there. Okay, so that is the last of the questions. We're going to let's give it just another 15, 20 seconds here. If this has spawned any additional questions, please feel free to put those into the Q&A panel. And Josh, any closing remarks on your side? Any additional things you want to add to this presentation?
Yeah, I guess I'll kind of leave you with, any questions that you have, whether they are constructive criticism or just a regular question. Please do reach out and ask us. We want to build the Qnect better and stronger, and we want to be able to do that for our users. And the only way to do that the way you guys want to see it is to get that feedback. Get the feedback and work with you guys diligently to make sure that what you're getting is, one, what you're expecting, and two, just pushing forward in the industry.
Yeah, that's good. Okay. Oh, one additional question has come in. Do you offer designs to CSA S16?
So right now, everything that we have is AISC, and we do ASD design and LRFD design. We are building more and more. We're looking into Canadian, We're going to be looking at European things like that. But for right now, it's AISC only.
And it should be noted too, so for this particular user, we'll send you a list of our connections, so you have that. And then we'll also, I think for other users, if you do have questions, other participants here, please feel free to reach out. Again, we're happy to evaluate a past project. We're happy to look at a set of design drawings. A lot of, I guess there's still quite a few people that are trying to understand what the best project for Qnect looks like, and we're happy to let you know if it's something that could work or not. And so, feel free to send those across. Again, my email address, this is Aaron Bartlett, and it's Aaron, Aaron, at Qnect.com. And Josh Hines is Josh at Qnect.com. So with that, we'll go ahead and wrap this webinar up. Thank you, everyone, for attending. Again, reach out with any additional questions, or if you're interested in evaluating a project with us, those are the best ways to get in touch with us. So have a wonderful afternoon. We'll talk to you soon.